2.1 picks up and kind of talks about something that we've done a little bit before, looking at what we call zeros of polynomials or finding roots. We talked about it for quadratics. When you have a quadratic, how many times can it cross the x-axis at most? Twice. And the two spots where it crosses on the x-axis, those are the zeros. So sometimes quadratic functions have two, sometimes one, sometimes none. If you shift that U shape up off the screen.
Oh,
you're good, yeah. All right.
And now I can just keep the scrap pieces?
Yeah, you're all done?
Yep.
Yep. You're welcome.
Where are you?
You too. Okay, let's graph this. Okay, this is a cubic. Put the calculator over here. We're going to type in 2x cubed minus 3x squared minus 3x plus 2. So I want to look at that. Hopefully we've got a graph that looks similar. And what I want to know is how many times does it look like that graph crosses the x-axis?
4 times.
How many?
3 times.
3 times. Yeah, it is going to cross 3 times. Now, I'm going to take this and I'm going to write this a different way. You're probably not going to know how to do what I'm about to write down, but you don't have to know how to do it. I just want to show you another way to write that, and I want you to notice that. Okay. So I'm going to write, when do I write it? Oh, I write it a different way in a second. Okay, so one more question first. When a graph crosses the x-axis, what is the y value of any coordinate if it's on the x-axis? Yeah, it's 0. And that's why this whole section is about finding zeros or roots. You're finding a number, like here's a really simple equation. You're finding a number you could fill in for x, and then the answer comes out to 0. In this case, it would be -3. -3 is the root or the 0 of that equation. -3 is also where it would cross the x-axis. So roots, zeros, and x-intercepts are really all the same thing. Now a line is a little bit simpler because it can only cross the x-axis 1 time. This kind of graph we're looking at, it crosses 3 times. When something crosses more than 2 times, okay, that means it's at least a cubic. And the only way you can really figure out where it crosses is to be able to take the original problem and factor it. Now again, you're probably not going to know how I factored that original problem. But what I'm going to do is just type that in and compare it to what I just graphed. If I'm telling you that it's the same thing, then when you graph it, this should look exactly the same. So let's type it in. Hit graph. And if you watch the graph in red that's about to be drawn, it traced on exactly on top of the graph in blue. Now, graphing something and saying that 2 pictures look the same, that doesn't really prove anything. Yes, the blue one and the red one look the same, but the only way to really prove they're the same is to FOIL this out. Okay? But I'm telling you, they are the same. Hopefully you can believe me by looking at the picture that they are the same. Now, we're going to come back to this, so just keep this in mind. And what I want to do now is find the exact places where this graph crosses the x-axis. In other words, find the numbers that you can plug in for x so the answer comes out to 0. Well, there's 3 of them. And here's how you find them. You have to do this 3 times. Under second calc, have we talked about option 2 yet?
No.
No. Okay, so option 2 is to calculate what's called a 0, okay, or to calculate where it crosses the x-axis. So we're going to go to option 2, and then it's going to ask you 3 questions. The first question it's going to ask you is to pick a point to the left of where you think it crosses the x-axis. So let's do the one on the far left. So move your cursor so that if you hit enter, it puts that vertical line in, and it's definitely to the left of where it crosses. Okay. Next question it's going to ask you is right bound. So you're going to move your cursor to the right of where you think it crosses, and then hit enter again. So now it's like it's kind of pinned in. It's going to look in between those 2 dotted lines and figure out where it crosses. The last question it asks is the guess. The guess doesn't really matter. You can pretty much just hit enter in this case. If you want to move it close to where you think it is, you can. Hit enter. And there is our first 0, -1. So -1 is a number that you can plug into this original problem. And if you do it all out, you'll get 0 as the answer. Okay, so let me put that one, let's put that over here. All right, and we got 2 more. Okay, so let's do the process again. Second, calc 0. Pick a point that you know is to the left. Pick a point that's definitely to the right. And now put your guess pretty close to it. And it gives me another answer. It gives me 0.5. So 0.5 is another number you can plug in. And you will get 0. And there's one more. Second, calc 0. Again, left, right, and guess doesn't really matter. And you get 2. So the 3 zeros that are the solutions to this equation are -1, +1/2, +2. Now, go back up to what we had up above. Does anybody see a connection between the -1, the +1/2, +2, and what's in that box right there? What do you notice?
If you set them equal to 0 and solve for it, you get the numbers.
Exactly. If you set each one of these equal to 0 and solve, you'll get those 3 answers. So that's how you find the zeros of a function without a calculator. You have to factor it, and then set each factor equal to 0, and solve. Now, whether or not you know how to factor that cubic, maybe not. Okay, probably maybe a quadratic you know how to do. There is a way you can factor some cubics, and we'll talk about that in another chapter. Okay, but I just wanted you to see the reason why you would want to factor something. It makes it easy to find the roots. But we use the calculator. So. Any questions on that one? All right, so -1, that was one of the roots. So let's kind of think about that number when you write this sentence. If -1 is one of the solutions to the equation when you set it equal to 0, then if you write -1, comma, 0, and put parentheses around it, that is the coordinate of the x-intercept. So the only thing that's different if I ask you for the intercept is you need to take the number you find and put comma 0. The intercept is a coordinate. The root itself is just the number -1. Okay, so if I ask for a root or a 0, you just give me a number. If I ask for a coordinate, well, you got to give me comma 0. And every x-intercept always has a 0 in that spot. We said that earlier. If it points on the x-axis, the y value is always 0. Now, that one's a little more complicated because it's cubic. So it had 3 roots. How many times can a line cross the x-axis that is not horizontal? Horizontal might be a special case. Yep. Right. Lines can only cross the x-axis one time. Whoa. Sorry.
When did you want us to use the coordinate point itself? This is the x-intercept you've been asked for.
If I ask you for the intercept, then yes, I want you to give me a coordinate.
But if you're asking for the root of the 0, just use the number.
Just use the number. Yep. So that's a linear equation. Sometimes you see mx plus b. I used ax plus b. It's the same thing. But if you wanted to solve this and get x by itself, how would you move the b to the other side? Subtract it. And then how would you move the a to the other side? Divide it. So if you have an equation that's linear, this is a very simple formula to find the root. You subtract the b and then divide by the a. Okay, this is kind of like the quadratic formula, but it's a lot simpler because it's for linear. And remember, lines can only cross one time if they're not horizontal. Okay, so now here's an equation, and I want you to find the root. What would the root be for this one? Yep. -3/2. What would the 0 be? I asked for the 0. Same thing. What would the x-intercept be?
Same thing.
-3/2, comma 0. Yeah. If I wanted the coordinate for the intercept. Okay, any questions on that? Okay, so that's linear. Now this is a step up. This is a quadratic. I already asked you, how many times can a quadratic cross the x-axis at most? Twice. So how many zeros can it have? It could have up to 2. It could have as few as 0. Or it could have 1. It all depends how you draw the parabola. These are all the different cases right here. Hey, you could flip them over too. But you're going to cross 0, 1, or 2 times. The discriminant will automatically tell you how many times. Because I know we talked about that. If the discriminant comes out negative, you don't get any crossings of the x-axis at all. If the discriminant comes out 0, it comes down, touches the axis, and goes back up. If the discriminant comes out positive, it's going to cross the x-axis twice. So all this does is tell you how many zeros you have. It doesn't actually tell you what the zeros are. To do that, you're either doing quadratic formula, factoring, or using the calculator and doing the left bound, right bound type thing. Okay, now this one says to solve, and it does say approximately. Approximately means we don't need the exact answer. If they don't need an exact answer, the calculator is fine to use. If they said solve and write an exact answer, then you have to use quadratic formula. Because quadratic formula would give you an answer like 2 plus or minus square root 3/7. Right? That's an exact answer that's not rounded. We're going to get a decimal on the calculator, but that's okay for this one. If we want to solve it, first, what do we want to get it equal to?
0.
Right. We want to get it equal to 0. I think the easiest way to do it is just like this. I just subtracted the 2x to the other side. If you say, well, what if I move everything to this side? Like minus the 1 and add the 2x. You'll still get the same answers. Your picture might look a little different, but you'll get exactly the same answers we're about to get. Your picture would actually be a reflection. That's all. All right, so now just type it in. -2x² minus 2x plus 1 I'll do zoom 6. I don't think we need to really adjust the window today for much. I can definitely tell what case this is right away. Is it the no solution, 1 or 2? Yeah, it's definitely the 2 solution. Okay, and what I'll do is I'll calculate the root on the left. If someone else can calculate the root on the right, that would be helpful. So second calc 0. Okay, left, right, enter. So the first root is negative 1.37. Or, there's one more answer. Does anybody have that second answer? 0.366. So that's going to round up to 0.37. As far as rounding, I'll always let you know on the test where you need to round to. So that's a quadratic. Any question on that? Yep.
Every time I try graphing it, I get a syntax error.
And you use the negative button down by the 3. Yep.
That is.
You got to use the negative that's under the 3. Yeah. The other one is a subtraction sign. Okay, so finding roots graphically. Let's just summarize how we did it. So you press second, calc, and then it's option, I think it was option 2. And then you have to do the left bound, right bound, it's only writing half my letters. So left round, right bound, and then the guess. And that's it. Second calc, option 2, left, right, guess, and it'll tell you the root. So that's something you will need to know how to do for the test. You hopefully have access to the graphing calculator we set up on the Chromebook the first day. So if you need to do that in the homework part of the test, you should be able to. Don't worry, we're not doing that. This is another cubic. Does anyone have a question on how to plug that one in and solve for the root? It's like the cubic we did at the beginning, and I did all 3 of them. Does anyone want to see one like that again? Okay, the only thing I won't go through all the stuff in like super detail, but the only thing is you got to remember is that exponent is not a guarantee how many times it crosses. It's like a maximum. So when you put in x cubed plus 2x, and then I would say minus the 1 to get that on the other side, because you got to get it equal to 0. Notice when you graph this one, it never really curves like the first cubic. It's like it starts to try to curve, and then it's nope, and it just keeps going straight. So cubics like parabolas don't always have as many x-axis crossings as the highest exponent. Sometimes they do, sometimes they don't. It depends. Yeah.
Sorry that this is like kind of like random, but with the test, the part that's going home.
Yeah.
Sometimes when like you leave test sites, it like is like invalidates your test, but like with like the calculator website, is it gonna be fine to like go then?
Yeah. Okay. I'll make sure that's okay.
Okay.
Yeah. Yeah. In class it will be, but from
Yeah,
home
yeah.
it will be.
Okay.
Okay. So when you solve this one, you're just going to get one answer. And it's approximate, so you just write down maybe 2 decimal places. That'll be good enough. So third degree polynomials generally have this look to them. And page 80 in the PDF shows you different ways that cubics can look. In general, they always look like one of those 4. I mean, the curve can be like a little bit bigger in the middle. It could do something more like that. It also doesn't have to be perfectly symmetrical. It could kind of go like, one side of the curve could be a little sharper than the other. That could happen. But they always look like one of those four basic graphs. And if you notice, all of these graphs go down forever on one side and up forever on the other. Down, up, down. Which means you are guaranteed to never get zero solutions. It's not like a parabola where you could shift it up enough that it misses the axis. I don't care how much you shift this up, it's never going to miss the axis because it always goes up and down forever. Depending on how you shift it or if it curves, that may control if it crosses the axis more than once. But it's always going to cross at least once. All right, so another cubic. Question here, just pay attention to what it's asking. How many solutions does it have? It's not asking what the solution is yet. It's just asking how many. What's the maximum number it could have?
3.
Yep, could have up to 3. Could have 2. Could have 1. It will not have 0. That's impossible. Minus 5x squared plus 6x minus 1. Okay, so hit graph, and this time we have how many solutions?
3.
Yep, so we have 3. And now it says just to find one of them. So I'm asking for the middle, which means the one that's the middle. So that one right there. Okay, what do I press to find the root? Calc? 2. Again, if I say root or I say 0, it's the same thing. Pick a point that you know is left. Pick a point you know is to the right. And hit enter. Okay, 1.55. Okay, that's the root, 1.55. Any question on that one? All right. So the last thing we're going to look at, and there's going to be one question on the test that ties in with this, is from 2.2 part 1. Okay, so in the last section, everything that we did, the standard window worked pretty good. But remember, you may have to adjust that window sometime to make sure you can see all the roots. Okay, one of the roots could be off the screen. So if you graph something with an exponent of 2, and let's say this is your window, and it went like this. Well, and this is your axis right here. If that's your window, you're going to see one root right there. But you're also going to see the graph curving. So you might have to follow that curve and figure out where it comes back up by setting your window bigger. So sometimes you have to adjust your window to see the roots. The calculator can't find the root if it's not on the screen. It won't work. So this is just kind of a general piece of information that I mentioned quite a bit. When we're solving problems, there's usually 2 approaches we take. Writing an equation is one, and graphing it on the calculator is another. It's exactly how we did quadratics. Right? When we talked about quadratics, we did projectile. I think when we did the projectile motion on that day, there was one question there we solved with quadratic formula. And I put the formula on the board. And then there was another question where we solved it with the calculator. So algebraic and graphic are the 2 main approaches that we take to solve problems. That's all that that's saying. Okay, so this will be our last question we look at. We're going to do a couple things with it, but there will be one on the test like this. It's going to be exactly like this problem. It's just going to be different numbers. So if you understand how to do it, put an example on your reference sheet.
Because you get like these exact numbers.
No. So in this problem, Bill has $20,000, and he's going to invest this money in two different accounts. Okay. Each account pays a different interest rate. The interest rate is how much money Bill's going to make. Okay. So one of the accounts pays a 6.75% rate. The other one pays 8.6%. And for these investments, there's all kinds of investments you can do. But we're doing what's called a simple interest investment. And that's mainly because the formula is very simple. Okay, it's a short, simple formula. Some investments are very complicated formulas. Or some investments are even unpredictable formulas like stocks or something. But this is a predictable investment. We know how much money we're going to make, or we can calculate it based on knowing the two percentages and the amount of money that's being put in the account. That's the formula for simple interest. It's I equals PRT. To calculate the interest that you make depends on three things. The principal, that's how much money you put in the bank or whatever it is. The rate, that's usually given to you in the problem. And then the time. You're going to make more money if you leave the money. You're going to make more if you leave the money in the bank for 5 years than if you only leave them in the bank for a week. Right? The longer you leave it, the more you make. Generally, time is going to be measured in years. We got to make sure the rate is a decimal. So if you had something like 12%, what would that be as a decimal? 0.12. So you have to make sure that any rate in the problem you use is changed to a decimal. Okay. So what they want us to do here is to write an equation. So we're not going to do as much of a graphical approach on this one. We're going to do more an equation. Find an equation that represents the interest earned in 1 year. The total interest. And remember, he's got how many different accounts he's putting money into? 2. So he's going to make some interest in the first account, then he's going to make some interest in the second account. We want to total it up. So what we have to do is we have to pick a letter and let that letter represent the amount of money that's invested in one of these accounts. It doesn't really matter which one it represents. It's whichever one you pick is the one you'll solve for first. Whichever one you don't pick, well, you'll get that answer second. All right, so he has $20,000. Maybe he's going to put $6,000 in this account, $14,000 in that one. That's what we're going to find out right now. How is he splitting up his money? So let's let X be the amount that's invested at 6.75%. So that means when we solve our equation, we're going to get the answer for this account first, and then the other account second. It doesn't really matter the order you get your answers in. So we're trying to find the total interest, but the first thing to do is find the interest in each account separately, one at a time. So let's start with the interest that Bill's going to make in the 6.75% account. We're going to use this formula to figure it out. I equals PRT. So the interest here is equal to PRT. P is the principal. How much is invested in the 6.75% account? Yeah?
X.
X dollars is invested at 6.75%. So that's the principal. We don't know how much of the 20,000 he put there. Some of it, maybe 1,000, maybe 2,000, 5,000. We got to figure that out. So that's the principal. P times R. What's the rate? I know it's 6.75%, but I can't have it as a percent. I need it as a decimal. Yep.
0.0675?
0.0675. Yep. And how long is Bill leaving the money in this account?
1 year.
1 year. So really it's times 1. We don't even need that. You can put times 1. Okay, so here's the formula. Just written the way we normally write something with a letter. Put the number in front. Okay, so that's the interest that Bill makes from the first account. Now we need the interest from the second account. Okay, so same formula. Principal times rate times time. So Bill had $20,000 to invest. He already invested X dollars in an account. How much does he have left for the 8.6? Yeah?
Y minus X?
So we don't want to introduce a different letter. But it is going to have minus in it. So it is going to be something with a minus. Yep.
20,000 minus X.
Right. 20,000 is how much he started with, minus what he already invested. So that's what he has left. 20,000 minus X. Times the rate. What's 8.6%?
0.086.
So 0.086. And again, times the time, it would be 1 year, but we don't need it. Now, this time, we have to do something a little different with this 0.086 than up above. What do we have to do with it? Yeah. So we have to distribute that out. So 20,000. 20,000 times 0.086 is 1720, maybe? Yeah, 1720. So 1720 minus 0.086x. What's that? Okay, I got tricks. It scales. So 1720 minus 0.086x, and that's that formula for how much money he makes in that account. Now, we want to know total. So he's making money here, he's making money here. What do we have to do with each one of them? We got to add them up. So the total is going to be 0.0675x plus 1720 minus 0.086. We'll just use our calculator and add those up. It's 0.0675. I can combine that with negative 0.086 because those are like terms. So we end up with negative 0.0185. So now, if you tell me how much money Bill invests, what was X again? 6.75%. So if you say Bill invests $5,000 at 6.75%, I could plug 5,000 in for X, and this will calculate how much interest he's going to earn in total. It's just the interest from the first account plus the interest in the second account, and I combine like terms. Any questions on the formula? And you can write I equals PRT. You put that on your reference sheet, if you want to put it down. And now we're going to solve for the amount in a second, but you need one more piece of information. You need to know how much interest did he earn, and then we can solve it. So right now, that's all you can do. Yep.
Is that just, you said that's the interest for both accounts?
Yep.
So
Because I took this box, I took box 1, I took box 2, and I added them together.
So if you're taking that and you say, like you said, put 5,000, doesn't that still leave a remainder to put into another account?
No, we automatically took that remainder into account when we wrote down the 20,000 minus X right there.
Oh, so you're putting it in that?
Yeah, the remainder, after you invest in the first account, the leftover is already built into this account with the 20,000 minus X.
So in that case, why don't you just put 5,000 and calculate it into the first account, find that, put 15,000 into interest at 8.6, and then.
You could, but then you'd have to use two separate formulas, do two separate calculations, and then add it up.
Oh.
I can just use this one formula, and it does the whole thing for me now. It does what you just said all in one step.
Oh.
Yeah.
Could you go back to the calculator real quick?
Calculator? Yep. Did I type something in wrong?
No, I just wanted to see. Okay, that makes sense. I wanted to see how you can put it in.
Oh, yep. Okay, not worried about that. Okay, so let's solve it.
Do we use the two separate equations as a method to do it, or do we have to strictly do it by the combined interest?
You might be able to, but the problem is I'm going to give you a piece of information like this on the test. I'm going to tell you that Bill earned a total of $1,509.10. I'm not going to break down how he earned the interest for you and say he earned $600 of it in the first account and then $900 of it in the second account. I'm just going to say he earned a total interest.
Okay.
So you're not going to have it broken down for you, so I don't think that approach would work.
Okay.
Okay, so he earned $1,509.10, and that's the total interest between the two investments. So how much did Bill put in the first account? How much did he put in the second account? Well, if they're giving us a number that involves the total interest, we need a formula for total interest, and that's what we just did. We have a formula for total interest. I need to write that down. What was the formula that we had? I know it was plus 1720.
Negative 0.0185x.
Negative 0.0185x. Okay, so that's the formula we came up with for the total interest. Now they're telling me the total interest. Where does that 1,509 get plugged in? Where the total interest is. And now we're going to solve for x, which is the amount of money that was invested in the first account. And once you know how much money was put in one account, well, it's easy to get the second account because he only has $20,000. Okay, so let's plug that in. And what would be my first step? Subtract the 1720. So we've got 1509.10 minus 1720. It's negative 210.9. Now at first you might think, wait a minute, that could be a problem because you can't invest a negative amount of money, but the negative is not going to be a problem in a second. How come? What are we going to do in our next step? Divide. And we're going to divide by a negative, so the negative is going to disappear. And what do we divide by? 0.0185. So it's gone from the left, from the right. The negative is gone from the left. And now, once we do 210.9 divided by 0.0185, we get a total of $11,400. And that's how much money was invested. X was the 6.75%. Well, he had a total of 20,000. So what's left if you subtract out the 11,400? How much?
8.6.
8,600. Yep. And that's the higher investment. Was that 8 point? What was the percentage on that?
8.6.
Oh, well, it's just a coincidence it came out that way. That usually doesn't happen.
That is a big coincidence. Did you plan that?
No.
I like it though.
Again.
You definitely calculated it all.
Yeah.
So the 11,400 is the 6.75. Is this the first one?
It's because that one is X, and at the beginning we said that X was the amount invested. Where did we say that? Right here. It's because we said X was 6.75%. If you said X was 8.6%, you could do it that way. But then you'd get that answer first, the 8,600, and then you would have got the 11,400 second. So you still get the same answers.
Okay, that makes sense.
You'll have different formulas, but that's okay. Let's put our answer back up. Okay. Any questions on that?
Is this going to be one question on the test or separate?
You'd have multiple parts, so depending on how much of it you get right, you could get different points. I think this would be at least worth 2 questions
So like
on the test.
So like on the test, is there like 3 questions for 1.6, 3 questions from the 2.1, like so?
I don't know exactly how it breaks. It is 12, and there's something from every section. At least 2 from each section. Yeah.
So yeah, because we're covering 4 sections.
So yeah, it'll be like 2 from each section, and then maybe one section would have 3. A couple sections would have 3. Okay, so the homework. So it's the take home. Okay, it's 6 questions. It's on edge elastic. And there's going to be a limit for how much time. Okay, so normally you would have 83 minutes to do a test. Well, maybe you'd have like 70, 65 minutes after you go home. So you'd have an hour normally to do a whole test. I'm going to give you an hour to do half a test. So you'll have 1 hour to do 6 questions. That 1 hour will not start until you start the test. Okay? Test will open at 2:40. Okay, so test is going to be open at 2:40. It is due by. What time is class tomorrow? We're period 3, so that's like 9:15.
Period 5 is period 5.
Yeah, so for period 5 is period 3. So it's due by 9:15 a.m. Eastern time. I've done this before. If it's late, it's a 0.
Also, you said we could use any material.
Due by 9?
Yes.
Oh,
Wait, we can use any material for this test?
Yes. You can use your notebook. You can use my video.
Can we get that in writing just so that way, like,
Yeah.
you said it?
To be fair, how about a notebook for when we're doing tomorrow?
No, tomorrow you get a
That's kind of
reference sheet.
the